Okay. I hope we're still here. Can you hear me? Hello, is anybody in the house?
Yes, ma, we can hear you. We can hear you.
Okay. Okay. So let me share my screen with you. Yeah. Let me run through what you just did. We talked about client, server, and the network being constituents of a full network system, and then that the client is the device or an application that requires data such as our phone, our web browser, our computer. Then the server being a computer or application that provides requested what resources such as maybe URL or any data that the client is requesting, and the network being the communication interface between them. Okay, so now with the procedure we mentioned that the client server communication follows a three part sequence that the client initializes the communication by sending a request. Then the request is sent to the server through our network, such as an internet or a LAN. Remember when it is a local area network, cables are involved, such as Cat5 cable, um, a router, a switch. Like router connects networks, your switch connects the systems. Let's say if I have three, four systems that I want them to share a common network. I use a switch to link them using a Cat5 cable or something. So for servers, they receive the information through the network, authenticate that it is a valid system. I don't know, I'm sure you've seen sometimes you see this a particular app will ask you to show that you're human. So that's part of the validation of your request. There is not AI just sending random requests. So they validate and authenticate your request and then retrieve the requested data and then serve it up through the network. Okay, so we talked about the types such as web browsing, such as your emails and so on. Then we also came here now to talk about the role, activity, results, and handling processes of both the client and the server. So we said the role-wise, clients request information, server provides information. Activity-wise, clients are active, servers are passive. Why? Because the one that initiates the communication, we say it is the active one. While this other one just waits until he receives request, then we can start. Resource-wise, servers consume resources while, sorry, clients consume while servers manage and, and share resources. Handling-wise, only one user can send a request. One user, one terminal, one application forwards a request of what it wants. Then a server can handle multiple clients' requests at the same time. Let's say the internet, we have 10,000 people, 1 million people in a room sending information at the same time. Auto, it will be slow, but will it provide the answers? Yes, it will serve up the requested data from different clients. So now this is a network. We have clients one, two, three. A network contains clients connected to each other in order to share data. Now, in this case, now we can have them connected, right? Using a cable. That's the one we're talking about, local area network. Basically, in a local area like a room, it could be two-story, three-story building. But what happens in that case is the cable you use for connection can only carry signal up to like 100 meters distance. So if it needs, let's say it's two-story building you're connecting. So if you need the signal to go beyond 100 meters that it is capable of carrying, you use what we call repeater. The repeater kind of repeats signal So it kind of increases the signal strength because the longer it takes signal, the lower the signal strength is. So after the 100 meters that it's capable of carrying, you can use a repeater to repeat the signal until you take it to where you want to connect it to. So yeah, a typical network here, apart from the clients, which are like your terminals, your systems, your nodes, there are several names you call the client. You can call it a node, you can call it a terminal. All the important thing is where information is sent out from. So, like if you go to the bank, most times they tell you there's no network, we can't check your account balance. There's no network, we can't do this. That's because what they are using is just unintelligent terminals that have to get the resources required from some other point somewhere, which is not immediately within their locality where they're sitting at the front office right there. So those things are just clients. You now want your account number, they request it from this server. You want to transfer information, they send out a request, and then the information gets to them. So if network is strong and network is good, they request it in no time. You won't even notice any lapse in real time. But if network kind of drops, they'll hang there, you will hang there, and they tell you, okay, this morning there's no network, come back tomorrow. Such stories. So now we have access points that connect us, that form the network that links us to our server this time. Access points will be switching or router. Okay. So there are different types of when we say access point, so the switches connect your immediate one PC, two PC, 3 can be connected to a switch. Some switch you have multiple switch like 24 ports, 8 ports, and so on. So, but we now have gateways, which are like the access points. Like a router now can come in. You have wireless router that does the job of connecting us to the network. So we have access point. The job of access point is just wireless connection. It provides a Wi-Fi connection that's wirelessly connecting us to the network. But we have also another access point called router. Wireless routers will do the same thing that your wireless access points can do with addition job, you know. For instance, apart from connecting you to the wireless, okay, like if I have a switch, I've connected all my systems to the switch. I can now use the switch connected to a router. An access point, there's something we call access point, specifically access point. Then there's something we call router. The router can do the job of the access point also. Why the access point cannot do the job of a router, cannot route. So the job of the access point is just to provide wireless connection to your internet or something. So, but the router, if it is a wireless router, can do both the job of routing your network to the appropriate channels and also providing a wireless connection. Okay. So here we have this example of what I just said. Because the information or you're requesting or the data you're requesting is broken down into packets. So they travel as packets. Okay. So we say the client connection to the network is usually through an access point. Remember I said we can have normal access point, which is wireless access point, or we can have what? In this case, I want to use router, which is also wireless router, doing the job of access point and also doing the routing. Okay, so the request sent from client or received from the server usually travel as packets. Now we have bits, we have frames, we have packets. So these are inside this. Bit is the smallest information, the unit of information the computer can carry. So as you now put the information together, they go from bit to byte and so on to frame to packets and so on before it can now travel through your network. I think maybe we need a class on that too, because by the time you send out your information or you're receiving the information, it comes in form of what you call packets. There was something I gave you to look at. I used Wireshark for it. So you see, if you put on your Wireshark, you receive packets flowing from Wi-Fi. You can choose to gather collect the packets from LAN. You can choose from Ethernet and so on. So those things flowing through any of those networks that you select, they are all flowing in form of what? Packets, data packets. So sorry, they flow in form of packets. So there is request and receive packets between each client and access point, and between access point and the internet. So I don't know what this means is that if you look at each of the clients, client one, two, three here, client one is sending requests to the access point. That's why I say there is what request and receive of packets. So client one sends to access point sends to the internet, right? Which is the resource that will provide the information. So the internet returns the requested packet to access point. Access point now gives back that requested packet to client one. So this is happening from client one to and fro. Client two is doing the same thing, sending and receiving packets. Client two is doing the same thing, sending and receiving packets. That's what it means. So if you have question, please write it down and we'll go through. Then in Wi-Fi networks, the packets are transmitted where your course is coming in now. In Wi-Fi networks, the packets are transmitted in the air because it's wireless fidelity, it travels in the air. And then if you have a wireless card and capturing medium, you'll be able to capture requests and responses that are within the range of where your capturing medium is. The example of this one is the Wireshark that we are using. If you have your capturing medium such as Wireshark and you have a Wi-Fi card, let's say your internet is on, and then you have the app called Wireshark. Once you switch it on, you'll be able to capture packets that other people are sending that are within the range of your system. So that means that any computer connected to the same network, you'll be able to view details, you'll be able to capture details, and you'll be even able to analyze details of the packets going through their system. Okay, so this is for introduction in this area. Then I'm going to stop this share and go through, I don't know how much time I have, and go to the second uh, okay, now let's go through this. Now, we did mention that if I have a medium for a capturing medium and a Wi-Fi card in my system, which we all have, that I'll be able to capture packets that are within the range of where my system is. So, and that brings us to the fact that if I'm going, my system packets, my neighbor can view them. Neighbor in my office, neighbor in my house or something has these things and is targeting me. That means you can actually also view the packets flowing through my system, capture them, and then maybe break into my system. So that brings us to our network security. Now, network security we define as what? Protection of networking components and connections, as well as the content. Protection of the components of my network, By this now, what are the components of our network? Our router is there, our wireless system is there, and so on. Then connections. What are my connections right now? I'm connected using, maybe I'm connected to um, a Wi-Fi system, let's say MTN Wi-Fi. I'm connected using my phone hotspot. So that's why sometimes you might not need to connect using your hotspot. You use a USB, to plug. We'll get to all that. It's not so, well, network security involves three things: protecting the components that you use for your network, protecting your connections, and protecting the content, the packet that is going through your network. So, we have hardware components. Network consists of hardware and software components. Remember, we are protecting what? Components and contents as well as what? Connection. So components wise, we have the hardware component and the software component. For the hardware components, we talk about the transmission media, which is your cable or your Wi-Fi, the hubs, the switches, routers and bridges, your firewalls, your modems, and your interface cards and so on. So all these form the hardware component. Remember, we say your server is a system somewhere or an application. So when you're still listing the software components, you can also be able to list your client as part of your software because it could be an application. Okay, so software components, we have the network protocols, we have the operating systems, and then we have the network software. Now, network transmission media. Under our transmission media, we think of whether it's guided or unguided. So we under guided, you look at the cables that are connecting, let's say the LAN. We have the twisted pair cable, we have the coaxial. Each one has its own speed. That's the speed at which you can carry data. So we have the twisted pair, we have the coaxial cables, and we have the fiber optic. The difference is the speed of um, at which it carries data. Fiber optic is the fastest. Then we have the unguided media. Unguided media are like our radio waves, that's the wireless medium. So in this case, you have the radio waves, microwaves, and infrared. Okay. Now, there's no when you talk about network without talking about the OSI model, Open Systems Interconnection Model. Now we have the 7 layers which form the OSI model. But in recent times now, of course, we are no longer talking about this OSI model. It has moved from these 7 layers and then compressed into just 4 layers. But in the 7 layers, I think it's more easier to understand these 7 layers. So when you compress it, you know the content of each one that has been compressed into the other. So in the 7 layer model, we have the physical layer. It is at this point that you talk about those your transmission media, signals, and so on. Then you have the data link, you know, which is the physical addressing, which has to do with your MAC address of each system that you're bringing to the network. Then you have the network layer, which determines the logical addressing and the path each one will follow. At this point, you talk about the IP address system. If you have 10 computers, you have to give each one an IP address. So sometimes you allow them to automatically determine their IP addresses, but it's safer to, assign IP addresses. So depending on your choice. Transport layer, we have the transport control uh, protocol and then the UDP. UDP is actually not that safe, but it's faster. Just the TCP is mad, right? End-to-end connections and reliability. So we prefer the TCP for transport, especially in the internet. The insertion layer has to do with handshake. They say it's theoretical, but it's at this session layer that the exchange happens, where the handshake, I use so and so, yes, an acknowledgement. So the transaction layer forwards whatever the data, and the handshake happens here. Data is exchanged, and then handshake based on acknowledgement of the data that you sent being received. Then data representation with an encryption, which kind of ensures that data is secure and data integrity happens. Then you now have the application layer where you now have your what do you call it again? Your HTTP, HTTP hypertext transfer protocol, your secure shell, which is the SSH, and so on. So it's at this point that you can now, because here we have the layer, we have the function of each layer, and we have the example, the protocols that operate at each layer. So, and I'm sure, I don't know if you have opened the, what do you call it, Wireshark, I can use it to capture network packets. You see that some of these things, like the IP addresses are there, MAC addresses are there, Ethernet are there. Then you also see the TCP protocols. I think I mentioned that how you discover your bad TCP, your good TCP, and then you also see your HTTP for posts and all those kind of requests. Okay. Uh, types of network. Some of you don't have computer science background, but for those that have, these ones are normal things that they already know. We have different types of network. Sentinel area network is not really important. It's just you and your PC. Then LAN, I already mentioned, LAN is multiple systems connected, but within a short range. Let's say in a, okay, I got disconnected. Maybe let me just take more time to complete the work. Where are you? Hello, I hope you are still hearing. I don't think you have more than 3, 4 minutes. Let me start right again. So in the LAN, you see computers 3, 4 connect. Let's say they want to share a printer. So three of them will connect to a switch or smaller one, which is a hub. And then the printer also will be connected to the same hub. And they'll all be able to share all the same printer. 4 people, 5 people, 10 people will be able to print from one printer. So those one is just a local area network. The metropolitan area network and wide area network are related. Just the area of coverage is the difference. Okay, so wireless area, these ones are not really too important at this point. This is an example of device sharing and network children. Okay, use cases. You have streaming video, sending file from printer to we just talked about that local area network, metropolitan area network, wide area network within maybe a 15. You go through this connection media for one. We have lead lines, whether it's wired or wireless, point-to-point connections. For wireless media, we have satellite used where wired infrastructure is not practical, and so on. So one classification based on topology. We have point to point. Now, this point to point can be circuit switching or packet switching. Actually, circuit switching has its own advantages, such as providing you with good bandwidth. At least you have enough bandwidth that will carry you. But in terms of resource management, they are not really that efficient. But we have the packet switching, which is what is in vogue now. We talked about packets and how data is moved through the network in form of packets. So this is what we actually use presently, packet switching, and there is resource efficiency in packet switching. Then beyond all this, we have what we call SDN, software-defined networks. This is a new, it's just coming in really from the time of COVID-19 because of how people suffer to get into one place to work. So software defined networks came in, and then you can now just, instead of connecting through all these lease lines, you have software routers, software switches, like virtualization basically. So you have virtual router, you have virtual, because if you're using the physical ones, all your companies have to be connected using physical routers and all that. And of course, that's a lot of investment in infrastructure. So, but in the software defined system, you just have this thing defined in form of software. You don't have to buy physical infrastructure, and then you get your router, virtual routers, virtual what do you call it, controllers for all the network. In a virtually controlled network, you have the data plane, you have the management plane, and you have the control plane. So all these three planes now make up what manages your network. The data plane at that level, then at the control plane, exchange happens, whether you're requesting. I will take my time to discuss software-defined networks. It's a full class on its own so that you see but just saying it in the past minutes will be so vague too. So we'll have a class on software-defined networks where you don't need physical routers that we are used to. We don't need physical switches that we are used to. So all those things will be in form of software. Okay, so I'll leave that for another class. Then the software-defined network, these are the applications that work there. You have your data center, you have your software as a service, and you have let's say you have headquarters in Owerri, and your branch is in Lagos. So in this case now, you don't need physical router here.